Good morning, students. Here we are making the video for the topic partial fraction. This is used in +1 sequence and series, and second in the +2 in integration. We are using the partial fraction, and this is only for a simple calculations form. So first we do the rational function. Before we start this partial fraction, so we know some terminology, and the first terminology here is that is called as rational function. A function, this is very important, a function of the form, a function of the form fx upon gx, where fx and gx, where fx and gx are polynomial and gx is not equal to 0, is called a rational function, is called a rational function. The second is proper, second is we call as proper rational function, proper rational function. Fx upon gx is called proper rational function, proper rational function if, this is very important here, is degree of fx is less than degree of gx. Degree of fx is less than degree of gx. And another important terminology is improper rational functions. These three important definitions are required for solving the partial fraction. The first is rational number, then proper, then improper. Fx upon gx is called improper rational functions, improper rational function if degree of fx greater than or equal to degree of gx, degree of gx. If the degree of fx is greater than or equal to degree of gx, then in such case we first divide the numerator by denominator by long division method, and write it as sum of a polynomial function, and proper rational function, by we are taking here one example. For example, Here is 2x raised to power 4 plus 4x minus 3 upon x cube plus 1. This is we have taken as example here. And you can see here the power of fx is 4 and the power of gx is 3 is gx is 3. If both the powers, the larger power is there, degree of numerator is greater than the degree of the denominator. 4 is greater than 3, so divide numerator by denominator. Here we write here, if degree of numerator greater than degree of denominator, that is here 4 is greater than 3, divide numerator by denominator till the remainder is a lower degree than denominator. Now we divide here. Here is x cube plus 1 and the term here is 2x raised to power 4 plus 4x minus 3. Here is 2x. The same coefficient for making this is 2x raised to power 4 plus 2x minus subtracting we have cancelled this. We left here is 2x minus 3 and here power is less than g, degree is less than. This is called as remainder and this is called as quotient. This is called as quotient. How we write this? 2x raised to power 4 plus 4x minus 3 upon x cube plus 1 can be written as quotient plus remainder 2x minus 3 upon x cube plus 1. Formula is quotient plus remainder upon divisor. And this is called as 2x. This is called as, sorry, again repeating this, this is called as polynomial. This is called as polynomial plus proper fraction, proper rational fraction. Another example we have taken here is x minus 2 into x minus 3 into x minus 4 upon 2x minus 1 into x plus 1 into x minus 5. Here degree of numerator is equal to degree of denominator, that is equal to 3. In this case, divide the numerator by denominator. Now this is the another method. Highest degree, that is higher degree of numerator is equal to 3 and highest degree of denominator is also 3. Then quotient is equal to x cube upon 2x cube. Here we can write as x cube over 3 and here is 2x cube over 3. x मल्टीप्लाई किया x cube, 2x x मल्टीप्लाई किया 2x cube, डिवाइड किया and here we left is 1/2. So this can be written as x minus 2, x minus 3 into x minus 4 upon 2x minus 1 into x plus 1 into x minus 5 can be written as 1 by 2 plus, without dividing here, something of degree less than 3 divided by denominator remains same, 2x minus 1 x plus 1 into x minus 5. Now we start with the partial fraction. Now we define partial fraction. The process of separating a given fraction means fx upon gx, into a group of fraction is known as partial fraction. The process of separating a given fraction into a group of fraction is known as partial fraction. For example, now we are giving the example to you here. That is very good example here is 2x upon x square minus 1. This can be written as 1 upon x plus 1 plus 1 upon x minus 1. Then 1 upon x minus 1 and 1 upon x plus 1 are partial fraction of 2x upon x square minus 1. ये इसके partial fraction बने हैं. तो case, there are many cases are there. So we discuss in the first video first case, when denominator contains, this is very important, contains a non-repeated linear factor only. And here is steps. How we solve the steps. Number 1, the given expression is in the form of a upon first linear factor plus b upon second linear factor plus so on. This is the first step. Second step, multiply both sides by the LCM, taking the LCM on the right hand side. And in the third step, find the values of a and b. Find the values of a and b by putting the value of x obtained by equating denominators of a to 0 in step 2. In step 2. And fourth is putting ABC in step 1. Putting A, B in step 1. This is the method. This is the method. Now we take one example here. 2x minus 1 upon x minus 3 into x minus 5. This is equal to A upon first linear factor plus B upon second linear factor. Taking LCM on a right hand side, and LCM is remain same as in the left hand side. Then here we get A into x minus 5 plus B into x minus 3, and this is equal to 2x minus 1 upon x minus 3 into x minus 5. This will cancel, and here left is 2x minus 1 is equal to A times x minus 5 plus B times x minus 3. Call this equation number 1, call this equation number 2. Now we want to find out the values of A, B. Now by putting first linear factor is equal to 0, and here we get x equal to 3. Putting x is equal to 3 into on both the sides. 3 to just 6 minus 1 is equal to A, 3 minus 5. 5 is equal to minus 2A. This implies A is equal to minus 5 upon 2. Again putting second factor x minus 5 equal to 0. This implies x is equal to 5 into we get 5 to the 10 minus 1 is equal to B times this is 0 and 5 minus 3. That is 9 is equal to 2A and A is equal to 9 by 2. Putting A and B in 1, we get 2x minus 1 upon x minus 3 into x minus 5 is equal to the value of minus 5 upon 2 upon x minus 3 plus 9 upon 2 upon x minus 5. Thank you.